Okay, just quickly, let's talk about how to address this problem. The problem is asking for the mass of Chris, so let's start by considering Chris as our object of interest. Here he is standing on the scale, holding on to the big ball, which is going straight upwards. So the scale is accelerating with, the ball is accelerating upward at 3 meters per second squared. Let's see what happens if we choose Chris for our object of interest. Force diagram for Chris. How many objects are interacting with Chris? Right? The earth, the scale, and what else? The ball. So, there's the force of earth downward on Chris. And there's the force of the scale. What direction is that? Well, it's going to be up. And is the ball interacting with him? Yup. What's the direction of the force of the ball on Chris? Well, down. Now, what do we need to know in order to find Chris's mass? Once we know the force of the earth on Chris, we know that that's equal to the mass of Chris times little g, 9.8. So if we can find the mass of the, the force of the earth on Chris, we can find Chris's mass. We know the force of the scale on Chris. So let's see, do we know the net force on Chris? Of course we do. He's not accelerating anywhere. So once we find the force of the ball on Chris, here's a statement for the net force on Chris. We know this one, and once we know this one, we can solve for this and get Chris's mass. So the question becomes, what is the force of the ball on Chris? Is it, let's see, that's a little thought experiment. Is it equal to the force of the earth on the ball? Well, here's where I want you to take it for yourself. Draw another force diagram for the ball and show the forces exerted on the ball. What objects are interacting with the ball? Only two. You know the acceleration of the ball, so you know the net force on the ball because you know the mass of the ball. So, do this and calculate the force that Chris is exerting on the ball. And then you can use Newton's third law to find the unknown quantity that you need in this expression. And then you'll be able to evaluate John's solution to this problem. Can't wait to see what you do with this now that you have some help. Feel free to talk with each other if you need any more help. End of lesson.